Lesson 3, square root functions and shifting. So when I take a look at this top portion here, it says square roots are operations on numbers that give exactly one output for a given input. So they fit nicely into that definition of a function, okay? You guys are real familiar with that. It says we can graph the general square root function, which we haven't done yet. So it says once we establish a very important fact about square roots. Well, that very important fact about square roots comes in exercise 1 here. And what I want you to do is I want you to consider exercise 1 in A and B. I want you to think about it. I want you to think about sort of your number sense and your mental math. I want you to play around with it on the calculator, because when you come into class, we're going to spend some time on this, and I want you to have some thoughts down. Because this piece here that it says that it's absolutely critical that you understand deep down inside. Okay, so this is a really big understanding. Play around with 1A and 1B and see what you can come up with, okay? That'll be our warm-up to start. So now it says consider, so now let's take and let's graph this. Consider f of x equals the square root of x. So this is our square root function, and this is the parent function. Okay, remember how we talked about the parent function for a quadratic with just plain old y equals x squared? Well, this is the plain old square root function. It's f of x equals the square root of x. Nothing fancy about it. Okay, so that makes it that parent function, and everything else is sort of generated from that. So it says create a table of values for input values of x for which you can find rational square roots. Okay, so we know what rational numbers are. So I'm just going to go real basic, and I'm going to pick, and you'll see why I'm picking 1, 0, 1, 4, and 9. Because my function is the square root function, so I can take the square root of 0 and say that it's 0, or the square root of 1 and it's 1, the square root of 2 and it's 2, and the square root of 9, or the square root of 4 and it's 2, the square root of 9 and 3. So I was picking some perfect squares. So because we're going to take them, now we're going to graph this function. So I did graph it on my calculator because I do like to look at it. Whoops. I like to look at that on the calculator first. See if I can get that out of the way. So that's what our square root function looks like. And now let's take those points that we generated on our table and go ahead and plot it. So 0, 0, 1, 1. We've got 1, 2, 3, 4, 2, 5, 6, 7, 8, 9, 3, and you can see what happens here. So there's our beginning point, and it does continue on to positive infinity, which brings us to our question in C. It says, what is the domain? Okay, so our x's of this function, and our domain looks like is x is greater than or equal to 0, or in interval notation, it is in fact equal to 0, so a bracket, and it goes on indefinitely to the right to positive infinity. So what's the range of this function? So we know that the range is our y value, so how high and how low does this function go? So the lowest point is 0. So y is greater than or equal to 0, because it does, as it continues to the right, it does continue up to positive infinity. So, or in interval notation, we'd say 0 to infinity. Okay. So part E says, circle the correct choice below that characterizes f of x, that characterizes our parent function. So is f of x always decreasing, or is f of x always increasing? Remember what f of x means. Okay, f of x is our y. So in other words, is our y is always decreasing, or it's a tongue twister for me today, the y is always increasing. And you can see that because it goes to positive infinity, our range, our y's are always increasing. It says, what shape does the square root graph appear to be half of? Okay? And this is not a coincidence. Okay? Okay, what does it appear to be half of? So I don't want to just give you that one. I want you to think about that one and come into class with that. And it says that it's not a coincidence. So what does it appear to be half of? Right? So we can come up with your answer on that one. Okay. Now let's go, and it says square root graphs can be shifted, just as our quadratics were. Okay. So again, going back to that parent function, well, now let's make it a little bit interesting. And how are we shifting? So they've already graphed the parent function for us, which is right there. It says use your calculator, graph the function given by this. Now be real careful when you enter this into your calculator. Notice that the 2 is outside the square root. Okay, the 2, that positive 2 is outside the square root, or in other words, it's not underneath the square root like the 4 is. So I already have my parent function graphed for us. So I'm going to go and graph this new one. Or this, I should say, this shifted one. So x plus 4, and then arrow out, so you're outside the square root, and then do that plus 2, and hit enter. And now let's make some observations. So how was it shifted from the parent function, mine is in blue, to the red function, that shifted function? What transformation occurred to it? And hopefully you're saying, okay, so if you started with sort of that beginning point, that 0, 0, you're going to notice that now that beginning point went back 1, 2, 3, 4, and it went up 1, 2. Back 4, up 2. So keep that in mind, and now let's go back to our graph here. And it says, show a table of values. Okay, so I'm going to give you that table of values. Let's go with these values. You guys know how to get to your table on your calculator. You hit Control-T to be able to come up with a table of values. So it starts at -4, +2, and then we have -3, 1, 2, 3, 0, 4, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. And that's what my shifted function looks like. Okay.
All red house.
Mr. Bear is talking on the announcements here. So looking at it, it says state the domain and range of this new function. Okay, so what is the domain? So how far left and how far right does this graph go? So the graph is greater than or equal to -4 or -4 to infinity. And then the domain, how low and how high does it go? So the lowest point, the lowest y value, is greater than or equal to 2. So from 2 to positive infinity. So now in part C, they're going to ask us to graph another function, a third function. So it's going to tell you, show your table, and then state your domain and range. I'd like you to do that one on your own. And then maybe I want you to make some observations here. Okay, I'm going to add to that. So you've got the parent function, you've got the one I just did with you in B, or I should say A. Now take a look at what happens in C, and jot some ideas down. What observations are you making? Meaning, look at your graph, look at your tables, look at where it starts, look at the domain, look at the range. What kind of observations? So can you put down? Okay. It does talk a little bit about it there, all right, but I want you to put it in your own words. Okay. So let's take this, you know what, I think I might have you guys do this function on your own as well. So now I'm going to talk you through a little bit of it. So the graph of y equals the absolute value of x, right? So we have the absolute value function. And that's the parent function for the absolute value function. Real basic, okay? And they've graphed it for us already. It says use your calculator to create a graph of that. Okay? And then they want you to state the domain and range of that graph in A. Now they're asking you, okay, let's see if you're starting to get the pattern. Now, go ahead and do that one without using your calculator. So again, make some observations. You're going to start to see some similarities occur, okay, between quadratics that we did last chapter, two square root functions, two absolute value functions, and we're going to kind of pull it all together. All right, so make observations, use your calculator, and get some good stuff down. See you guys in class.